is a Bunsen burner, correct?
Yes.
Now, I don't want to start the Bunsen burner with high ratio of the gas. This is the gas here. This is the valve here for the gas, and this is that's the valve for what? For the oxygen. In order to have total combustion, you have to have a very good ratio to start with. I will start closing all those valves. That's the gas. Close here. Look at guys. I will close this valve here all the way. Correct. I'm closing it. Close all the way, and close the oxygen all the way. Correct. So if I'm not doing this and start blindly just put the flame, it might the flame be very high gas, very high oxygen, might go to burn the ceiling, correct? So now, 3 rotation, 1, 2, 3, correct? And 1, 2, 3. 3 rotation of the oxygen, air, and 3 rotation of the gas. So then I have to have it here secured, so it will not flip or anything will happen to it. So here it is. Make sure you put it here. So now carry this one here a little bit up. Open it here. And you have to have your goggles all the time. Your goggles. You don't have to. So now I have secured everything, and everything looks good. Secured. Hand tight, not over tight. Now when I put this one here, I have to make sure that I can put this one aside first. So we have the stand, we have the iron ring, we have the triangle to hold the evaporating dish number 1, correct? And this is evaporating dish number 2 with the wash glass, correct? So leave it here aside, and we'll have a metal net. Use it for cooling the evaporating dish. We don't want to shock the evaporating dish ceramic from whatever 600 degrees on the bench 15 degrees. That's large. So we'll put it in the metal so it will cool down very slow, correct? The metal net here. So now, what should I do? Should I put striking the match towards me or of my body? This way or this way?
Away.
Away? Perfect, perfect. Somebody has done the quiz. So I'll turn the gas, not all the way, so a little bit, and then try to see if it will turn on. So it might not turn on. Let's try it. Yes, turn on. Now, you can see it started with the flame is blue, which I like. If it started with the yellow, it means cold. Cold flame is not. So now I can add a little bit of gas, of air, for complete combustion, correct? And then I can pull this one here aside and pull this one here more towards the bottom of the whole thing here. Let me just pull it here. Yes, so now everything is tight. From now on, I have to use my fingers. No, my fingers will be what? Barbecued, correct? I don't want to barbecue my finger, correct? So, what we call this? Tongue what? For cooling or heating? Crucible tongue or heating tongue. That's just always for hot stuff. The other one is for what? For beakers. And this is for crucibles or evaporating dish. See the difference? Mm-hmm. So, there's another tongue here. I don't see it. Tongues means holders. So if you have, there's a test tube holder. You see the test tube tongue. So we have 3 tongues. This is for the beakers. This is for hot objects, and we have the test tube tongue. And then we have, if you look at this, we have the purette tongues or purette holder. Here it is. Let me show you here. That will be experiment number. I don't see it here, but yeah, we don't have it, but it has a special, let me see it maybe here, if we are lucky, find it here maybe. Yeah, here it is. So now we have, how many tongues? Okay, so somebody will show me the test tube tongue. Where's the test tube tongue? Where's the test tube? This 3-year test tube down here. I don't have it here, but. So how many tongues we have here? 4. So we will be using all the semester those 4. This is a burette tongue or holder. This is a beaker tongue or holder. This is a crucible or evaporating dish holder or tongue. And then the last one here, somebody has this one here. Yeah, show me that. So now we will be using those 4 tongues or 4 holders throughout the whole experiment this semester. So 4 tongues means holder. So this is test tube holder or tongue. This is burette, especially just for the burettes, especially for the beakers, correct? And this is for what? For hot objects, crucibles and evaporating dish only. You cannot use this. If you use this, somebody had used this. Can I tell that? Yeah, some of the rubber will be already gone, correct? It's barbecue. No, that's not correct. This one just for beakers. So now we have this tongues, and make sure that you follow the orders there. So I'll keep them here. This is today, nothing with your fingers. So I have this one empty. Go and weigh the sample, record the sample number with empty, and then add to it 3 grams, correct? And then weigh the whole thing with the 3 grams. It might be 3.03. It has not to be exact 3.00 grams, so 3 point something, but it has to be 3 grams. So now I did always use this to support you, correct? And then you will put it here. You'll heat it till all the smokes is gone. Sometimes the ammonium chloride is crystals, is mixed with sodium chloride crystals. So what you will do here, you get the steering rod, not the rubber side, no, the glass side, and try to stir the sample a little bit to make sure that the crystals will come apart and so ammonium chloride will evaporate. Until the whole thing is evaporated, dish number 1, correct? Take it up, cool it down. Then you go and then weigh both of them together. That's dish number 2. Weigh them together, correct? So now I have the mass of both. Here it is. This already cooled down. Go and what? Go weigh it like this. Carry it like this. So here it is. So now we are ready. This is good. So now I will add to this what? 10 ml of what? Distilled H2O. Distilled H2O. Because I don't want to use tab. I don't know what's inside the tab. Will have maybe a little bit of effect on the mass. I don't know what they have inside, but distilled, at least we know for sure there's nothing there. Just except H2O, pure H2O inside. So you will weigh this one here. You add 10 ml of H2O, and then with the help of the steering rod, make sure that sodium chloride is out of the sand crystals. So just make sure and decant. Decanting means all the liquids out, leaving what? Leaving the sand, the solid there, correct? So the 10 ml will not do it. We'll add what? Another what? 5 ml, stir a little bit and take the liquid the other side, correct? Now, this is the liquid, sodium chloride separated by itself. This is by itself is sand, wet sand. I'll take this one here, put it in and let it dry let's dry really, evaporating all the H2O inside. And you can tell with the help of the steering rod, you can tell if it's wet or not wet. The crystals, when it's dry, will be fluffy, correct? Fluffy, I can move them very easy. But when any crystals are wet, you see them what? They come clumsy. See, the word clumsy versus fluffy, fluffy is dry. Clumsy means what? There's H2O still sticking with the crystals. So you have to, if it's clumsy, you have to reheat it again to make sure that's dry. Now it's dry. I take what? This one here. This one is solution, correct? Sodium chloride. Put it in and then start dry. When it starts dry, you'll see white crystals coming in. If you're still heating it, it starts popping like a popcorn effect, correct? So to start popping the crystals, you lose crystals, you get less yield. So in order to have this, you have to cover it with what? On the top here, cover it with watch glass. Correct? Let's cover it with watch glass. So that's the whole thing is preventing the crystals to come popping out of the evaporating dish number 2. Correct? So now when you are done with this, done with all this crystal is white, and you make sure that there is no condensation is here. If it's condensation, that's still wet. Correct? When it's dry, okay, so now get it down. This one is already cooled down to room temperature. Go and weigh. You weigh this one here. Correct? The dry sand. Then once this one is done, just take it up here and take it the whole thing, and you weigh both of them together, because you will both of them empty, both of them filled with sodium chloride together. Correct? Because this one here will have some crystals underneath of the white crystals of sodium chloride, and the difference then you do the calculations. Now, there's a lot of time when heating and cooling. There's a lot of time. So therefore, what we'll do here, we'll do an experiment to do the physical properties of some compounds. And come and see here. What with me here? You'll have out of this vials here. Look at this. Those are about 5 vials with 5 different elements. 6, correct? Those are 6 vials, and you can tell what's inside. So then you have to fill, which is already filled for you here. See here? See those 6? So what will happen here, you can see here, the results already given to you. I added another column for the number of the neutrons. So what we are looking for, first of all, aluminum. So you go to aluminum here. Here it is, that's aluminum. Look at the periodic table. What's the atomic number of aluminum? Correct? What's the atomic mass? Number of the protons, number of electrons, number of the neutrons. You have to add what? You have to add really another column, because if you don't, I will take some points. 5 points I will take. Because we have to know what's the number of neutrons. Correct? And then you classify this element by metal, non-metal, or metalloid. So aluminum is a metal, correct? Atomic mass is 26, atomic number 13, number of the proton 13, and number of the electron 13, and this number of the proton is 13, and so on. And then you take even here, sulfur here. Do not open them. You don't need to open them. You just observe them here. That's a bright yellow, correct? And here is the color. You can look at, oops, sorry. Here you can look at the color here. Sulfur is here, what? It's bright yellow. Atomic number is 16. Atomic mass 32. Number of the proton is 16. Is non-metals, correct? This number of the protons, number of electrons, number of neutrons. Then you will come to the silicon. The silicon is here. The silicon is, this is the silicon, as you can see. Can you see? Silicon is a metalloid. You can see it here. It's bright. It's shiny. See here? That's silicon here. And you can go all this here. Atomic mass 28, atomic number 14, number of the protons 14, number of the electrons 14, number of the neutrons 14, and it is metalloid, correct? So I want you to go with the group while the heating and cooling takes time. Do and look at those. Do not open them, just look at them, and try to match your data with the data I have for you here. So you don't have to memorize everything. The data is given to you, and I give it all to you, but you have to add another column for the number of electrons. Any other questions you have? Any other questions you have? Okay, let's start doing the setups. Yeah, thank you.